Hi everyone, welcome back to Advanced Functions, MHF4U1. This is a new chapter called a Trigonometric Identities and Equation. In this lesson number 1, we are going to explore what is a equivalent trigonometric function and identify the relationship between the two. First, we have to understand what RAA stands for. So RAA is a related acute angle. So acute means that it has to be less than 90 degrees, and related means it has to be related to a standard angle. So first, let's take a look at in the first quadrant, quadrant 1. So we have a triangle in quadrant 1, and I represented related acute angle as letter A. Okay, so right now, related acute angle is letter A. In quadrant 1, we can say that this is also our principal angle, or a standard angle. Because the reason why it's standard is always the angle from on a Cartesian plane is from the positive x-axis to the counterclockwise. That is the direction that the principal angle or the standard angle starts from the initial arm over here to where the terminal arm is located. This is theta or angle A. So in quadrant 1, my principal angle is equal to my related acute angle. Now let's take a look at quadrant 2. So in this case, my related angle is letter A, and my principal angle or the standard angle is from my initial arm to my terminal arm. Okay. Now, related acute angle, one characteristic that you have to understand is it's always based on the x-axis. So for example, this is my x-axis and this is my y-axis. So let's say I have my terminal arm over here, 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 and here. So if it's in quadrant 1, my related acute angle is from the terminal arm to the x-axis, which is here. This is my related acute. If it's in quadrant 2, it's always x-axis to your terminal arm, which is over here. That's my related acute. And if it's in quadrant 3, again, based on the x-axis to your terminal arm, this is my related acute. And if it's in quadrant 4, that means from the x-axis to my terminal arm. This is my related acute. So therefore, in quadrant 2, this represents my related acute based on the x-axis. In quadrant 3, again, the related acute is from x-axis to my terminal arm. So the blue line that you see is the principal angle or the standard angle. And in quadrant 4, related acute is from the x-axis to where your terminal arm is. And the blue line that you see from initial arm to your terminal arm is the principal angle or the standard angle. Now, so let's take a look at equivalent expression. So equivalent expression is that where you can interchange depending on the angle and the sign of the ratio. So let's say this is my Cartesian plane. So everything here in quadrant 1, sine theta is sine theta. Cosine theta is cosine theta. Tangent theta is tangent theta. Now, to do the equivalent expression, like I said, the related acute angle is based on the x-axis. So if we think about the x-axis, this is 0. And if the angle is from all the way here this is going to be pi. And if we're going all the way to another x-axis, this is going to be 2 pi. So if we have a terminal arm in quadrant 2 here, that means sine is equal to pi minus theta. Okay, but on the other hand, cosine pi minus theta, theta in this case is my related acute, is equal to negative cosine theta. Okay, and on the other hand, if we have tangent, so tangent pi minus theta is equal to negative tangent theta. Let's say I have a terminal arm over here. So to find this angle, always theta represents the related acute in this case. So if I have, let's say for example, cosine, so all you need to do is to find this related acute is always 180 degree, which is a straight line, minus my principal angle. Okay, so that means is that cosine pi 180 minus theta is going to give me negative a cosine related acute. So I'm going to write theta in this case is related acute angle. Okay. Now, so for in quadrant 3, you will notice that it's pi plus related acute. So again, it's 180 degrees, all the way here, 180 degrees plus my related acute. Okay, that's where you get the equivalent expression. And if it's in quadrant 4, that means it's going to be 2 pi minus related acute, because it's going to be 360 minus related acute here in this case, and that will give you the equivalent expression. So I will definitely show you this in the next few slides by doing an example. Before we do go over this, this is a cast diagram. Oh, so it's a little bit hidden here. So what a cast rule is that in quadrant 1 is all of them, all the 3 ratios are positive. S in quadrant 2, only sine is positive. So cosine and tangent is going to be negative. In quadrant 3, only tangent is positive, so sine and cosine is negative. And in quadrant 4, only cosine is positive, so sine and tangent are going to be negative. So how do I remember this? So draw the quadrant, and you can remember cast like this, starting from quadrant 4. Or if you have a hard time remembering, you can think of this acronym. So all soup turns cold. Okay, so please remember which quadrant that you want to start with. If you want to start with cast, you start from here and then that way. But if you want to start remember by acronym, all soup turns cold, then you're doing the C pattern this way. Okay. Now another concept that you have to understand is cofunction. So cofunction identity, it describes the trigonometric relationship between a complementary angle. So as you can see, if I'm given theta, then the other angle is obviously it's going to be pi over 2. Pi over 2 is 90 degrees minus theta, because another angle is 90 degrees. So if this is, let's say, 20 degrees, then the other angle is going to be 70, because 90 minus 20 is going to be 70 degrees. So cofunction only works in a right triangle. So for example, sine theta is equal to cosine pi over 2 minus theta. So it makes sense because sine theta, let's say here, is the ratio is opposite. Let's say, let's label this. So this is A, B, C. So in this case, sine theta is equal to opposite over hypotenuse, C. And then, so cosine of this angle, which is pi over 2 minus theta, so cosine from this position is going to be adjacent over hypotenuse. So it's exactly the same ratio. So cofunction, it represents the same ratio but using a complementary angle of a 90 degrees triangle. Okay. So cosine could be represented using a sine, and tangent could be represented as a cofunction with cotangent. Okay, so let's do an example. So use the cofunction identities to write an equivalent expression. So let's see. So from the previous slide, we said sine theta is cosine pi over 2 minus theta. So sine, I'm going to write down the formula, is cosine pi over 2 minus theta. In this case, my theta is pi over 6. So then I'm going to make a common denominator. So cosine 3 pi over 6 minus pi over 6 is equal to cosine 2 pi over 6, which we could reduce. So the equivalent expression is cosine pi over 3. So that's what how you use a cofunction identity to figure this expression. So what this means that whatever the ratio of sine pi over 6, so in this case, it's 1 over 2, cosine pi over 3 is also going to be 1 over 2. So they're exactly the same. Next, we have cosine 5 pi over 12. The cofunction identity for cosine is sine pi over 2 minus theta. So we have our theta, sine pi over 2 minus 5 pi over 12. So make a same denominator. So sine 6 pi minus 5 pi over 12. So sine is equal to pi over 12. So that is going to be my equivalent expression using a cofunction identity. And lastly, we have tangent. So the tangent, the equivalent expression is the cotangent, pi over 2 minus theta. So let's plug in my theta. Cotangent, pi over 2 minus 3 pi over 8. So let's make a same denominator. So it's going to be 4 pi minus 3 pi over 8. So cotangent is pi over 8. So this is going to be my equivalent expression to the given tangent. Next, it says write an equivalent expression using a related acute angle. Now there are different steps to this that you have to remember. So first, when you're given the angle in radian, it might be a smart idea to figure out what this is in degrees, so you can figure out which quadrant it's located. So remember, to go from radian to degree, all you need to do is multiply by the conversion factor, 180 degrees over pi. So I'm going to do 7 pi over 4. So pi and pi cancel, which is great. So 7 times 180 divided by 4, it will give me 315 degrees. So we know what we're going to do. We are going to draw where the terminal arm, so 315, it's going to be located here. This is 315. But we have to find my related acute. So my related acute is always x-axis to my terminal arm. This is my RAA. So to find my RAA, remember I told you to only use the x-axis angle, which is pi, 0, and 2 pi. So to find this, all we're going to do is 2 pi minus 7 pi over 4. And make the same denominator, which is 8 pi minus 7 pi over 4. So that is going to give me pi over 4. That is my related acute angle. Okay. Now, second thing that you have to remember is the cast rule. Using a cast rule, so I'm going to write CAST. Now, my terminal arm is located under C. Only C cosine can be positive, but I'm given sine. So therefore, my equivalent expression is going to be negative sine pi over 4. The reason is because only cosine can be positive in this quadrant, but I'm given a sine ratio, so sine in quadrant 4 is going to be negative. So this is my equivalent expression using a related acute angle. Next, tangent 5 pi over 6. So again, I'm going to do a conversion. So multiply 5 pi over 6 times 180 degrees over pi. And when you simplify, it's going to give me 150 degrees. So let's draw on our Cartesian plane. 150 is located in quadrant 2. This is 150. But we have to figure out my related acute. So related acute is from the x-axis to my terminal arm. So that means I have to use pi. So I have to do pi minus 5 pi over 6. 180 degrees minus 150. So make the same denominator. I'm going to get 6, so it's 1 pi over 6. That is my related acute. So the next thing is we have to consider a cast rule. CAST. So as you can see, my tangent is located under the sine. Only sine can be positive here. So therefore, my equivalent ratio, it's going to be negative tangent pi over 6. If you think about it, if I were to give you sine, that means your equivalent expression is going to be sine pi over 6, because only sine can be positive in this quadrant. Okay, so lastly, cosine, negative 2 pi over 3. So don't worry about negative. Negative tells you that it's going to be going in a clockwise direction. It tells you which direction your angle is going. So let's change 2 pi over 3 times 180 times pi over pi, and it's going to be 120 degrees, and it's negative. So because it's negative, I'm not going from my initial arm, I'm not going counterclockwise, instead I'm going clockwise from initial arm. So from here, I'm going 120 degrees, which is going to be located here. So from all the way here, this is negative 120 degrees. Now we have to find related acute from x-axis to my terminal arm. So related acute in this case is pi minus, now don't worry about negative, we're not going to include negative. We're only considering the angle, which is 2 pi minus 3. Okay, negative is just only for direction. So when you make a same denominator, 3 pi over 3, which is going to be 1 pi over 3. That is my related acute. Now we have to consider a cast rule, CAST. My cosine is located under the tangent quadrant. Only tangent can be positive. So therefore, it's going to be negative cosine pi over 3. So that will be my equivalent expression using a related acute angle. So when you're doing this, number one step, change it into degrees. And number two, if it has negative, that means it's going in clockwise direction. If it's positive, you're going counterclockwise. And after you draw it plotted out, find the related acute angle using pi or 2 pi formula. And then after using a cast rule, and figure out if my equivalent expression is going to be positive or negative depending on which quadrant is located.